In this video, we're discussing question 17 on practice exam 3.1 in the fall 2021 semester in Chem 1211. And the question is very simple, simply stated anyway. Select all of the polar covalent bonds from the list. So the concept, of course, at the heart of this question is polar covalent bonds. So let's talk about what a polar covalent bond is, shall we? So polar covalent bonds are those with an asymmetric distribution of electrons. One of the atoms in the bond, one of the two atoms, has a much greater electron density than the other, where the definition of much very much depends on your situation, shall we say. If you're a student watching on YouTube in a far-flung corner of the globe, ask your teacher what they consider a polar covalent bond is. For our purposes, a good rule of thumb is an electronegativity difference of 0.4 or greater. And very often for exam questions, you won't see anything that's even close to that cutoff, because when you get close to that cutoff, it becomes ambiguous whether we should consider a bond polar or not. But really what we want to be thinking about here to address this problem is delta En, the difference in electronegativity for the two atoms in the bond. So the electronegativity of X versus the electronegativity of Y. And of course, without a table of electronegativity values, we're not going to be able to make that determination relative to 0.4. So I'm actually not even going to pull up. Well, I tell you what, let's pull up the periodic table, because you'll have access to periodic trends and we can at least assess the difference qualitatively in electronegativity between the two atoms involved in the bond. So CH, for example, carbon and hydrogen are pretty close in the periodic table. Carbon is slightly more electronegative than hydrogen, but CH bonds are generally not considered polarized because these elements are similar in electronegativity. So CH is a nonpolar bond. Let's go ahead and write that down. CH is nonpolar. And molecules that contain only, for example, CH and CC bonds are generally considered nonpolar as a whole. Now, NH is definitely a polar bond. Nitrogen is considerably more electronegative than carbon, and of course hydrogen is still hydrogen. The electronegativity difference here is certainly large enough to produce a polar bond. And nitrogen is one of those elements that you should kind of think of as electronegative by default. It's not as electronegative as oxygen and fluorine, and its relatively low electronegativity relative to those elements does matter, particularly when you get to organic chemistry. But for the time being, this is definitely a polar bond based on what we understand about electronegativity and bond polarity. CO. Well, again there, CO, oxygen is one of the most electronegative elements on the periodic table. CO is absolutely a polar bond, polarized toward oxygen with the electron density mostly on the oxygen. Of course, in NH, most of the electron density is on the more electronegative nitrogen. NaO. Well, Na is on the far left side of the periodic table, and O is on the far right-hand side of the periodic table. Looks pretty damn polar to me, right? But hold on a second, take a breath. Covalent bonds. Is NaO a covalent bond? Na is a metal, and O is a nonmetal. And so these will not engage in a covalent bond at all. These will engage in an ionic bond. And so we're not going to select that, not because the bond is not polarized. In fact, it is extremely polarized. We're not going to select that because it's an ionic bond, not a covalent bond. BBr. Okay, wow. BBr. In terms of polarity, we probably need electronegativities in order to figure this one out. So let me go ahead and turn on the electronegativities so that we can get a sense of this. 2.04 versus 2.96. Pretty polar bond. Pretty polar bond based on the electronegativities. So let's go ahead and put BBr in the list of polar bonds. It is definitely a covalent bond, right? Because bromine and boron are both nonmetals. And then finally, CC, of course, is a nonpolar bond because the two elements involved are identical. A carbon-carbon bond is nonpolar. And this is true generally even if the carbons are connected to different stuff, suggesting that one carbon has more electron density, maybe because it's being pulled on by other things, right? than the other carbon. Generally, we think of C-C bonds as nonpolar in any case.